So let's talk about states of matter. Okay, this chapter it deals with the states of matter. Means there are three states. Normally, we usually discuss about solid state, liquid state, and another one is gaseous state. Okay, in solid state, we know that the molecules present inside the solid state is very close to each other, and the intermolecular force is very high and the distance is low. Okay, in the liquid state distance is much more than solid state, and the intermolecular force gets lower. In gaseous state intermolecular force is almost nil. Okay, in ideal condition it is really nil. Okay, in ideal gaseous condition or ideal gas, yes, principles. Okay, and the distance between the two molecules is far away. Okay, the molecules used to move very freely. Okay, now let's get intermolecular forces. So intermolecular forces means it's nothing, the forces between two molecules. Okay, that may be cohesive in nature or adhesive nature. What is cohesive force and adhesive force? Cohesive force is like when one molecule of a substance is attracting another molecule of the same substance, then it is known as cohesive force. When one molecule of a substance is attracting another molecule of other substance, okay, other substance, other substance or compound, then it is known as adhesive force. Okay, intermolecular force. So van der Waals force are there, it is very less in amount, the amount is very low, and the force acts only to some extent, only to some distance, up to a distance. Okay, after that it does not occur. Okay, so now London force is also there. Now let's come into this one. Okay, dipole forces. Okay, dipole forces means, dipole means two poles. Okay, two poles, positive pole and negative pole. When the two poles present in a molecule simultaneously, then the molecule is known as dipole molecule, like HCl, hydrogen chloride. Okay, in here in HCl, hydrogen acts as positively charged, partially positively charged. Okay, and Cl is negatively charged, partially negatively charged. What it means by partial, it is actually when like H plus and OH minus, it is fully charged. Means H plus is having on positive charge, on positive amount, on positive unit of charge. Like proton is having proton have how much? One unit positive charge. Like this only H is also having 1 unit positive charge, then it is H plus. But in case of HCl, hydrogen chloride, H is having partially charged, not fully charged. That means it is less than the 1 unit of positive charge. Likewise in Cl also it is less than the 1 unit negative charge. 1 unit negative charge, where it is located, 1 unit negative charge, like electron, the charge of electron is actually 1 unit negatively charged. Okay, so dipole forces. When HCl, on a molecule of HCl, hydrogen chloride, interacts with another molecule of hydrogen chloride, then this is known as dipole interaction, because every HCl molecule is dipole in nature. So one molecule of HCl when interacts with another molecule of HCl, both are actually dipole in nature. So this interaction is known as dipole interaction, and the force, the attractive force acts between these two is known as dipole attractive force. It may be repulsive as well. How? Because HCl have partially positive charge and partially negatively charged also, so negatively charged as well. So part of the positively charged H plus, when repels H plus of another molecule, then it is repulsive. And when H plus of one molecule is attracting another Cl minus of another molecule, then it is negative attractive force. Okay, so next it is dipole induced dipole forces. Dipole induced dipole forces means presence of a dipole molecule, non-polar molecule is getting dipoled. This is known as dipole induced dipole forces. So see here, like AB, here AB molecule is having delta plus and delta minus charge, So it is dipole molecule. A is positively charged and B is negatively charged. When this molecule comes in contact with some non-polar molecule, like in right side it is shown, so this molecule will get induced by AB molecule, and this non-polar molecule will get partially positively charged and partially negatively charged. Partially positively charged, which part? The B part. B part is having negatively charged, so it will induce positive charge in close proximity with this in the non-polar molecule. So thus the non-polar molecule gets polar, okay, dipole in nature. This is known as dipole induced dipole interaction. Okay, so next, hydrogen bond. Hydrogen bond, when hydrogen bond occurs, hydrogen bond when hydrogen atom is attached with fluorine, oxygen or nitrogen, like fluorine, oxygen, nitrogen. We know that in these three elements actually very electronegative, highly electronegative element. Okay, highly electronegative. Then what they do actually, when hydrogen and nitrogen are bonded, then nitrogen as nitrogen is more electronegative, much more electronegative than hydrogen, so it will attract the electron pair towards it, the bonded electron. Okay, the bonded electron, it will attract the bonded electron towards it. So thus nitrogen will act as N minus, means negatively charged, and H will act as H plus, so positively charged. This will lead to polar bond, and this when this H plus attracts another nitrogen of another molecule, then it is hydrogen bond. Then the formation of bond is known as hydrogen bond. Same only. When hydrogen is attached with oxygen or fluorine, then hydrogen gets positively charged and oxygen and fluorine gets negatively charged. This negatively charged oxygen or fluorine will attract hydrogen of another molecule. This will make hydrogen bonds. Okay. So we need to remember nitrogen, oxygen, fluorine. The most electronegative is fluorine, then oxygen, then nitrogen. Okay, it is in sequence of atomic number. Fluorine is most, then oxygen, then nitrogen. Because in the periodic table we know that from left to right, when we go, the electronegativity increases. So that's why from nitrogen, then oxygen, then fluorine is the more electronegative. Okay. So next, thermal energy. So let's talk about thermal energy. Thermal energy. Thermal means when temperature increases, the thermal energy increases. When we supply some amount of heat in a system, then it gets thermal energy, and by this, when in thermal energy increases, the molecules present inside the matter, maybe solid, liquid or gas, that they tend to be more movable. They tend to have more kinetic energy. Thus, if in case of gaseous state, this will cause more pressure on the wall. Okay, so this wall pressure will increase. Thus, thermal energy is directly proportional to the pressure on the wall. Okay, in gaseous state especially. So now coming to intermolecular forces and versus thermal interaction. So intermolecular forces means the force between two molecules. That intermolecular forces gets lower by thermal interaction. Means when we increase the thermal energy of a system, then the molecules present there gets higher energy, higher kinetic energy, highly movable, highly randomness, that will cause more pressure on the wall, and this will lead to the distance between two molecules getting lower. This lower distance, sorry, this the higher distance will cause to less intermolecular forces. Okay, thus intermolecular forces is indirectly proportional to the thermal interaction or thermal energy. More the thermal energy, intermolecular force is less. This is the relation. And another thing here we must mention, that the by increasing the randomness, entropy increases, because entropy is the measure of randomness of a system. When we increase the gaseous system, when we increase the thermal energy of a gaseous system, the gaseous molecules tends to move much more than earlier. So this goes far random in nature, and this randomness This randomness creates much more entropy in the system. Thus, more the thermal energy, more the randomness, more the entropy. So up to now, so for now this much. I will talk later remaining part. Okay, so study hard, get a good rank, get into your dream college. Thank you.